Hi guys, welcome to Read. Welcome to Potter's Network Room. And before us, we've got simple topology here. If you can look at this, we've got a layer 3 switch here, and we've got an ISR router, and we have a simple setup. Like how on this setup, we're actually trying to demonstrate some IP NATing, and we're also trying to demonstrate basically some VLANs. I'll have to record another video where basically just going to talk about VLANs in depth, but just a brief description of VLANs. VLANs are actually virtual lines, and these actually help us to reduce the size of the broadcast domain in the network. So suppose we've got a network where we've got the HR department, we've got the sales department, we've got a marketing department, and if all of these departments are actually attached to this switched network and there is no VLANs attached to the network, then that simply means that anybody actually in any department can send a broadcast, and that broadcast will be sent out to all nodes on the switch network, and that actually can cause a lot of noise on the network and can actually increase on the bandwidth utilization. So in order to actually cut off that, we have VLANs, and VLANs actually help us to reduce the size of our broadcast domain. So, well, if you look at our VLANs here, we've just got two VLANs. We've got VLAN 20, while we're having a PC here, and we've got VLAN 10 on another PC. So in our demonstration, we just want these two PCs to actually access the server on the other end. Okay, so let's dive into it. So we're going to put our console on on the switch, and on the switch, basically what we're going to configure the VLANs, and we're actually going to configure the VLAN routing. Okay, awesome. So here we're on the switch, and the first thing that we're actually going to do is to go into the enable, and let me just enlarge this so that you should be able to see this better. Awesome. Going to go to configuration mode, global configuration mode, and here the first thing that we want to do is to actually create the VLANs. So we've got VLAN 20 and VLAN 10. So for you to create the VLANs, all you have to do is actually say VLAN 10, and that VLAN is actually created. You can Control Z to exit out of that. Awesome. So let's create VLAN 20 as well. So VLAN 20 is created. Okay, when we look at our network diagram here, we can see that actually on VLAN 20 on this switch, it's actually connected to the port FA020, and VLAN 10 is actually connected to port FA010. So what we're going to do is that we're going to configure those ports. They're actually access ports, and we're going to talk more about the access ports, the trunking ports, and we're going to talk more about that in the next video, where we're actually going to talk about VLANs or specifically. So we're going to exit out of this, and we're actually going to go to the interface FA0/10, and what we're going to do here is that we're going to actually tell this interface switch port mode access, and we're going to say switch port access VLAN 10. Okay, my bad. There's some typing error there. It's supposed to be switch port access VLAN 10. So we're using tab to actually complete our commands, and next we're going to exit out of this interface. We're going to go to interface FA0/20, and we're also going to do switch port mode access and switch port access VLAN 20. Okay, so once we're done with this, next thing that we're actually going to do is to do our IP addressing. So our IP addressing is actually we're going to do our IP addressing on the interface of the VLAN. So we're not going to actually put this IP address on the actual ports. Rather, we're actually going to put them on the interface. So to do that, we're actually going to exit out of this, and we're going to go to interface VLAN 10. My bad. Then we're going to say IP add 192.168.10.10. We're using a /16.255.0. Then we're going to exit that. We're actually going to go to the interface VLAN 20, and its IP address is actually 192.168.20.20, and using the /16 suddenly. Save our configuration. Awesome. And exit out of that. Okay, so the next thing that we're going to do, we're using a layer 3 switch. So for us to enable this port here to actually send the traffic to the ISR, we actually have to disenable the layer 2 functionality. So what we're going to do is actually we're going to go to this interface here. We're going to assign it an IP, and we're actually going to enable the routing so that we should be able to communicate here. Okay, so we're still on the same switch. Awesome. And on the same switch, we're actually now going to go to the interface. That's 0/1. So on this interface, we're actually going to issue this no switch port command. It's actually going to disenable uh, the switching functionalities. And the next thing that actually we're going to do is to actually add an IP address on this interface. So as you can see on the diagram, we actually had put 192.168.1.1. So there we go. And we're going to put our seedant and not shut on head. Awesome. Next thing we're going to actually enable routing. So we're going to say IP route. Sorry, IP routing. My bad. That's a command actually when enabling routing on the layer 3 switch. So we have to issue the command IP routing. So we're going to use route OSPF here actually as our routing protocol. You can name the process ID anything, so you can just put it out OSPF1. And now let's advertise our networks. So here we are. Let me show you this. So we are supposed to advertise this network here. Okay, so awesome. So now we're actually going to say network 192.168.0.0.0. Then we're going to issue the wildcard mask. Then this is in area 0. It's going to be on the backbone. So once we do this, we can exit out of this, and we're actually going to configure a static default route on this. So configuring static default route is actually a pretty easy command. So we're actually going to issue an IP route, and it's routing statically. So it's going to be 0.0.0.0.0, 0.0.0.0.0, exit interface, which is going to be 192.168.1.2. Awesome. So the 1.2 is the next interface on the ISR. Okay, awesome. So you can save the configuration there, and that's it. for the switch. So now we're done for the switch. What we can do is that we're going to take our console and we're going to put it on the ISR so we can exit that terminal. Awesome. Awesome. So we're going to go to global configuration mode. So one thing that we actually have to do on the router now, our main interest is to actually get have the router to do our NAT. The reason why we actually having the ISR in place is because we the layer 3 switch actually don't have the NATing capabilities built into them. So for our private IPs, which are these IPs here, in order for them to communicate to this server, of which this server is actually, if you can look at the configuration of this server, it is actually on a public IP. So you're fine to say that for them to actually be translated and for these private to communicate to the outside world, we're actually going to need NAT. That is network address translation. Okay, awesome. That being said, we can actually dig more into it. Okay, let's go to our router here. Awesome. So the first thing that we're going to do on the router is to actually do some addressing. So what I'm going to do is I'm going to go to the gigabyte on this router. We've got this side, which is the gigabyte 0/0/0 and the gigabyte 0/0/1. So this is actually our ingress and this is our egress interface. So here we are. So we're going to go to interface gigabit 0/0/0. Gonna add an IP address here, and that's 192.168.1.2. Remember, on our static default route, the exit interface was this IP address. Awesome. That's going to be 255.255.0. Awesome. And we're actually going to exit out of this interface, and we're going to go to the interface of gigabit 0/0/1. Awesome. We're going to put our IP address in, which is actually going to be 209.1.1.1. And sorry, my bad. I have to put IP odd. 209.1.1.1. It's going to be 255.255.255.252/32. Awesome. Okay, what else are we supposed to do? Let's finish up with our routing. We had started an OSPF router on the 3500 series switch, so we're supposed to actually now finish it up on the ISR for the configuration to be complete. So we're using OSPF, and the process ID was 1. So we're going to advertise some networks here. Network 192.168.1.2, and we're going to advertise only this IP. So we're going to use a wildcard mask of 0.0.0.0, and the backbone area is 0. Awesome. We're also going to advertise the network of 209. Okay, so you can see that now OSPF has formed an adjacency with this neighbor here on this gigabyte interface, and it's in a full state. Okay, awesome. So we can put another network, and that is 209.1.1.1. We're only advertising this network, but we're connected to the backbone. Awesome. Okay, that being done, we can now actually proceed and configure some NAT. So before we proceed and configure some NAT, we're actually going to configure the interfaces. So when I go to gigabyte, interface gigabyte 0/0/0, there I'm going to say IP NAT inside. Why is it inside? When you look at our network diagram, this traffic is coming from here, going this way. So this is definitely our inside, and this is our IP NAT outside, which is gigabit 0/0/1. So you can exit out of this interface, then you actually go to interface gigabit 0/0/1. The IP NAT outside. Awesome. So you can exit out of that. So we're actually going to create an access list, and this access list is actually going to permit our IPs to actually go through the SAM. So we're just going to actually create a standard access list. So to do that, we're going to say access list. We can call it 1. So we use a permit, we issue permit statement. What networks are we permitting? 192.168.10.0 wildcard mask, and also going to permit.20. Awesome. And after doing that, since we have created an access list here, we can now proceed and create our NAT. So for us on this actually on this network, I would love to actually create a pool. I don't want to do an interface command. Uh, I want to actually create a pool, and this pool is actually going to communicate. So for me to do that, actually what I'm going to do is I'm going to go into the same global configuration mode here, and I'm going to say IP NAT pool, and we can name a pool anything else, anything, but it's case sensitive. So we're going to name it NAT 208, whatever. So our pool is actually going to be 209.1.1.2, 209.1.1.4, and net mask. Our net mask is actually going to be 255.255.255.248. I'm going to use the /29. Awesome. That being done, we can actually now issue out our IP NAT inside, IP NAT inside, what I mean, source list, one. The reason why we're using the source list 1 is because our access list, we named it 1. So IP NAT inside source list 1, and we call our pool NAT. We named it NAT 208. It's an incomplete command. Let me see it. Oh my god, IP. I made a mistake here. My bad. Awesome. That being done, that simply means that actually we have we've configured our NAT. And what's next to do is for us to actually test our configurations. So we're now actually going to check our configuration. So let's try and access the web browser. Let's do 0.9.1.1.2, and bam, we're able to. Let's go to the terminal. Let's try and see what's actually going on the router. Can exit out of this. I need some show commands. Show IP NAT translation, and we're able to actually see some translations there, and we can see some statistics here. That simply means that our configurations are actually working. Can actually check. Okay, so here we are. So we're sending a TCP request, and as you could see, we're actually accessing the web browser. So that simply means that was the protocol we're using was a TCP. So this is our inside global, and we were assigned a port, and our inside local is actually coming from this VLAN, and our outside local was this IP. If you remember, our IP pool had from this range to 4. So we were translated to this IP as our outside local. So if you loved the video, be sure to actually leave a like and please subscribe to the channel and be on the lookout for the next video. In the next video, we're actually going to talk more about VLANs and why they're important to the network. Well, thank you very much for watching. It's James Potter.